In intermediate algebra, you'll be asked to factor the sum and difference of cubes, perfect cubes. We've already factored the difference of squares, perfect squares. Here's what we mean by the sum and difference of cubes. Mathematicians figured this algorithm, this process, and recognized that if I had an expression, let's just talk variables, a plus b times a squared minus ab plus b squared, that would result in what we call the sum of cubes. And I'm just going to show that real quickly to you. If I would multiply this out, a times a squared is a cubed, and here I have a minus a squared b, and here I have a plus a b squared. Now I'm going to multiply the b times every term in the second polynomial, or the trinomial. I have here a positive b times a squared. I'm going to write it in this order, a squared times b. And here I have a minus a times b squared. I'm lining up the like terms. And right here, b times b squared is a positive b cubed. When I collect all the terms here, these two add to be 0, and these two add to be 0, leaving me with just a cubed plus b cubed right here. What we're going to learn is when we recognize that we have a polynomial that is a perfect cube, each of the terms with a plus sign in between, we'll factor it into this format. When we have a minus sign in between, we'll factor it into this format. These two statements are listed in your book, and you need to memorize them. Here's how I remember them. This is the sum of cubes. We'll have a plus sign in the binomial. Always, in each of these cases, in the trinomial, the first term will be a squared. There will be an ab and a b squared. This sign of the second term does not match that sign, and always the third term in the trinomial will be positive. Look at this one as well. It's positive. When I'm factoring the difference of cubes, I will have a minus sign in that binomial, a minus b, always a first term squared. This sign will not match this sign. It will be the opposite, a times b, and again, always a plus sign in front of that b squared term. What we're going to be looking at is factoring something like x cubed plus 8, or it could be x cubed minus 8 for that matter. This would be an example of something that's a perfect cube, and it's the sum of. I know that because I can take the cubed root of 8. The cubed root of 8 looks like this, and what it means is what number times itself 3 times will give you 8, and 2 times 2 times 2 does give me 8. If this variable term is raised to a power that's divisible by 3, then it is also a perfect cube. Let's do an example. If I were going to factor the sum of perfect cubes, in this case x cubed plus 8, I would be looking to write this as the product of a binomial times a trinomial. Inside this binomial, I have to put what we call a and b here, which is the cube root of this. Or, because this is a third power, I'm going to use x, and the cubed root of 8 is 2. Maybe another way for you to think of that is to think of what number to the third power will give you 8, and in this case, what letter to the third power will give you x cubed. Again, I'm going to put these in parentheses. That might help. It's this x and this 2 that has to go inside that first binomial. Next, what we want you to do in the trinomial here, we want you to take whatever's here and put it in this spot and square it. So take this, put it in this spot, and square it. Next, because this is the sum of cubes, I want a minus sign here. And I want you to take a times b, or whatever's in this parentheses, in this case x and 2, or I'm going to write it as 2 times x, and write it as your next term. Finally, always a plus sign here. I want you to take whatever's the last term in this binomial, your b value, and I want you to square it. Well, 2 squared is 4. And I factored this perfect cube, the sum of perfect cubes, into x plus 2 times x squared minus 2x plus 4. I can multiply that out to check it and see that it works. A much harder problem, but still the sum of cubes. I'm looking to write this as the product of a binomial times a trinomial. First, let's think of what number times itself 3 times. In this case, 5 cubed will give me 125. And x cubed will give me that x to the third power. So I'm looking for you to think of the first term in your binomial to be a 5x, because 5x times 5x times 5x, or cubed, is 125x cubed. Next, I want you to ask yourself what number times itself 3 times gives you 64. That's a 4. 4 cubed is 64. And again, that y raised to the third power is that y to the y cubed. I need you to think of using a 4y as your second term, and when you cube that, you'll get 64y cubed. This 5x and this 4y are what we call our a and b. I need to put those in the front of the binomial, or in the binomial in the beginning of this expression. Again, a is my 5x, b is my 4y. I now want to take a and square it. I want you to take a, 5x, and square it. In a minute, I'm going to write that down as 25x squared. Next, bring down your minus sign, and I want you to take whatever a is, in this case 5x, and whatever b is, 4y, and I want you to multiply them together. So 5x times 4y. I'll call that 20xy in a minute. And finally, I want you to take our b term, which is this 4y, and I want you to square it. Put that in parentheses because I want that to become a 16y squared. I've got to clean this up before I finish. And so the first in the binomial, 5x plus 4y, this 5x, that quantity squared, is a 25x squared. A minus sign here, 5 times 4 is 20xy, just bring those along. And 4y times 4y is 16y squared. I factored the sum of cubes into the product of this binomial times this trinomial using this algorithm. I'm going to factor a problem that's called the difference of cubes. It behaves the same as the sum of cubes, and I can see here quite readily that this number 64 is a perfect cube because I can take 4 and cube it to get 64. The y as well, and I'm going to write this as 4y, that quantity cubed. The number 1 is a nice number. When you multiply it times itself, you still get 1. So I will take 1 and cube it and still have the number 1. So I'm ready to factor 64y cubed minus 1 into the difference, here in the first parentheses, 4y minus 1, that's my first factor, this binomial. And now I need to take, again, I think of these as a's and b's. I need to take this first term and square it. So 4y squared is 16y to the second power. I always want a plus sign, that's part of my definition. I want to take the product of 4y and 1. That is just 4y. And then I want to take and put a plus sign, and I need my last term, this 1. It is just the 1 that I'm squaring, and that gives me 1. I'm done. I factored the difference of cubes into the binomial 4y minus 1 times the trinomial 16y squared plus 4y plus 1.